For message-based flow controls, we can start with circuit switching. It's a technique that operates at message level with the coarsest granularity. So we have more techniques with finer granularities, but first let's understand what is circuit switching. This technique pre-allocate resources across multiple hops to entire message. So what it does is it sends a probe. Probe is a small setup message. It sends this message to the network and reserve the links needed for transmission of entire package from source to destination. Then once this probe reaches the destination transmits an acknowledgement message called ACK back to the resource. Then this source receives the acknowledgement message. It releases the message, which then travel quickly through the network. Then further messages can be sent from the source to the destination. Once message completes its traversal, the resources are deallocated. So as I have explained in this diagram, here from source 0 to destination 8, we will understand through this time space diagram how circuit switching works. So during the first 5 cycles, a setup message from node 0 to node 8, then an acknowledgement from cycle 5 to cycle 9. Then you can see at cycle 5 we have S to 8. This is a setup message from source 2 to request resources between 2 and 8. So the acknowledgement blocks this message and move forward. Then at time 10, data starts transmitting from source to destination, and D represents the data message. So the data message travel in a pipeline manner. At cycle 12, you can see there is no data for the source to send. Then again at cycle 13, the source send new data. Then cycle 14, the source send the data. At cycle 15, there is no data again. Sorry. Yes. So then cycle 16, we have tail. Tail is the last flit of the message. This way, the transmission of data from node 0 to node 8 finish at node 20. Also, the resources are deallocated. Starts deallocation at node 19 and source 2 starts to set up its link. Now we have some merits and demerits associated with the circuit switching. First is after the setup phase, per hop latency to acquire resources is avoided. Now if we have large messages, this latency reduction can amortize the cost of original setup phase. In addition to possible latency benefits, it also provides bufferless transmission, as links are pre-reserved and buffers are not needed to each hope to hold packets that are waiting for allocation, thus also saving power. Though latency can be reduced, but it suffers from poor bandwidth utilization. The links are idle between the setup and actual message transmission, and also other messages cannot use those resources are blocked.